this famous quote that if it could be demonstrated that any complex organ existed, which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. And he goes on to say, but I can find no such case. I think there are a few problems with this, just the way this is phrased. I think Darwin was wrong to set the evidential bar so high when he says could not possibly. In science, especially in biology, biological systems exist on a spectrum of probability. So we shouldn't talk about possibility or impossibility. Those categories are too inflexible, too rigid. So we have better to talk about perhaps it could be rephrased as which could not probably have been formed by numerous successive slight modifications. Another thing as well is perhaps one example would do the trick in some ways, but I do think the way scientific theories function is that they're much broader than a lot of people think. So, you know, if there's kind of one anomaly that crops up within a broader scientific theory, like evolutionary biology, there's always some auxiliary hypothesis we can kind of attach onto it to kind of explain some of these anomalies. So I don't necessarily think it would be a case of just finding one single system. So in some ways, I'm making it harder for myself, but I do think there is a burden of proof to shoulder as well as the kind of naturalist. When it comes to biology, I do think there's a kind of systemic kind of theoretical inadequacy, and this biological world is just chock full with some of these systems, these complex specified systems, which we'll talk about in a second as well. He said that an irreducibly complex system is a single system composed of several well-matched interacting parts that contribute to the basic function, wherein the removal of any one of the parts causes the system to effectively cease functioning. So Behe wrote that in Darwin's Black Box in 1996, which is a very kind of well-known book in this area. Now, in my view, this definition that Behe gives, it's kind of a good, gets you in the right ballpark, but I think there are a few issues with it. Further down the line, William Dembski kind of enhanced the definition. I think it was in his book No Free Lunch, and he kind of plays around with a few different definitions to kind of make it a bit more rigorous. So it's a bit of a mouthful, but a system performing a given basic function is irreducibly complex if it includes a set of well-matched, mutually interacting, non-arbitrary, individuated parts, such that each part in the set is indispensable to maintaining the system's basic and therefore original function. The set of these indispensable parts is known as the irreducible core of the system. So that's a bit of an elaboration on Dembski's original definition. There are quite a few definitions out there. So that's a bit more of a rigorous one, I would say. The obvious one is the bacterial flagellum. This is the kind of poster child of the intelligent design movement. It's basically an outboard rotary motor that allows bacteria to swim in the watery environment. It's kind of embedded in the cell membrane. It's got these it's got all these kind of key parts, so the bushings, universal joints, stator, O-rings, a rotor, and it seems that all these parts are kind of essential to the functioning of the overall system as a bacterial flagellum. And Behe basically says, even if a system is irreducibly complex and thus cannot have been produced directly, so Behe's saying that this problem of irreducible complexity it's a barrier to direct Darwinian pathways, basically. So it's not impossible that these could have arisen by natural means, but it's more that that there are kind of pathways, indirect pathways, that Darwinian mechanisms could navigate to produce this system. But the more complex the system that we're looking at, the probability of these indirect routes being found kind of drops precipitously. So it's not necessarily a barrier to direct pathways. I think that's a key point as well. There are a lot of objections to this. There's kind of co-option objection. People like Ken Miller have proposed this kind of precursor system, which is the type 3 secretory system. So there's a few objections in that area, but I'll get to those later on.
Yeah,
that's it. This is
okay.
Ken Miller's point about because often the mousetrap is used as an analogy for an irreducibly complex system. You've got these 5 parts, and if you remove one, it loses its function as a kind of effective mousetrap, or even an ineffective mousetrap. Ken Miller makes this point of you can kind of remove parts of it and use it for other functions, but that's a kind of misunderstanding of the argument. And I think even in Darwin's black box, Behe anticipated this objection, and he's not arguing that there are other functions that the bacterial flagellum could have used along the way, but these kind of these intermediate steps aren't exaptation. Yeah. Oh, I'm just looking at creation myths comment.
Yeah.
He assumes function has to stay the same. Yeah, that's not true. That's not true. He doesn't assume that. He has addressed that in many places. He's well aware that there are other functions that it could have served, but whole point the code. Yeah.
Mm-hmm. But the point is, like, if exaptation, how many functions would have had to change in the evolutionary process? Like, it's just to me, it's unrealistic to think that at every point every mutation could be part of, or like, it's just I don't know. I don't find this to be a good explanation at all. But.
No, there are. I mean, the problem gets worse. There's when we're talking about sort of this co-option scenario, exaptation, a philosopher, I'm trying to remember his name now. Oh, Angus Maynooth. He kind of again, he sharpens the kind of exaptation point, and he lays out these criteria that need to be met to solve this problem. So. For a working flagellum to be built by exaptation, the following 5 conditions would all have to be met. So the first one is availability. Among the parts available for recruitment to form the flagellum, there would need to be ones capable of performing the highly specialized tasks of paddle, rotor, motor, and such other things. So that's one problem. It's just the availability of all these parts that are needed for the whole unit. Synchronization is the availability of the parts to be synchronized at the same point, either individually or together at the same time. And so then it's like an availability problem again, and coordinating all these parts kind of coming together. Another one is localization. So the selected parts must all be made available at the same construction site. So they've all got to be localized to actually start working on the job. Another one is.
Can I pause you really quick, Joshua?
Yeah, sorry.
I just want to say, it looks like we've got Dr. Dan a little bit fired up, and Dr. Dan,
sorry,
I mean, you're good. You're good. This is his job. But I mean, that means I think you're making some very good points here, and Dr. Dan would like to respond to them. And Dr. Dan, so I just invite you to come on Examining Evolution anytime and share about the exaptation that you say is everywhere. Tons of functions would have to change. It happens all the time. He has a lot of other comments. So, of course, I want to hear both sides of the conversation. And so you're welcome to come on. So go ahead. We're at localization, I guess.
Yeah, just one other thing. I mean, yeah, of course, functions change all the time, but they're not on their way to another, for example, the bacterial flagellum. Of course, there could have been other functions earlier on, but they still don't get, they're still not on their way to being a bacterial flagellum. They're still, they're doing other jobs. That's what I'd say. That's what I'd say about that, just briefly. But yeah, there's a lot more to be said on this. Where was I?
You were
coordination.
Yeah,
that's it. Yeah. So the parts must be coordinated in just the right way as well. So even if all the parts are available in this localized manner at the same time, there needs to be some kind of ordered manner in which they kind of come together. Otherwise, there's a lot of things that can go wrong. And then this last one is interface compatibility. So the parts must be mutually compatible. So they must be. This is why in the definition, Behe mentions is that the parts must be well matched as well. They need to be capable of interacting and being put together in the right order. So that's those criteria are often ignored as well. I think that kind of poses a really big challenge to these exaptation scenarios that are often proposed. Are we okay to move on?
Yeah, great.
Cool. Where are we? There we go. So, sorry, just one sec. I've lost my.
No problem.
Go. I'm on it. Just to kind of bring that, just kind of move on from that. This is just an example of some of the recent research that's been done on the bacterial flagellum, because Darwin's black box is, decades old now, and a lot of these issues have been hashed over. So there's three really interesting papers by Waldy and Schultz. Just to be upfront, this is from the kind of biocomplexity magazine, which is at the bioinformatics lab, which is an ID-friendly kind of institution, journal type of thing. So this is obviously coming from an ID perspective, but these are really interesting, great, well-researched papers that have been peer-reviewed as well. So these are kind of looking at the bacterial flagellum from an engineering perspective, and there's three. You can just see a few snapshots of the three papers there. So cool. You can find those on the biocomplexity website. I think they were done this year and last year, so they're fairly recent, those three.
Very good. There's your papers, Dave. Let me know when you get done reading them.
Asking for some papers. Yes, there's plenty on this. Just another example. This one isn't talked about as much. So another irreducibly complex system that you could argue for is these magnetotatic bacteria. So they're kind of a group of prokaryotes which are have their direction of the motility sort of influenced with the magnetic field. There's a quote there just from a paper. Now, with this sort of thing, this diagram here is some kind of possible intermediate stages of how the end product might have come about. But the important thing with this one is all these pieces need to be in place, and they also need to be fully functional before there's any benefit to the bacteria itself. So there's this kind of long, circuitous process before it even gets to what it needs to be. So I think there's some real problems there.